In this question, we're going to look at using Suvat in 2 dimensions. Now, how do I know that this question involves Suvat? Well, the question says we are accelerating uniformly. And we always use Suvat whenever we have a question with constant acceleration. Okay, we're working in 2 dimensions, so rather than Suvat, we often use R to represent 2-dimensional position. So we're going to think about R, U, V, these are all vectors, and then T is a scalar. Okay. Worth noting in the question, it says that we have I is in the easterly direction and J is in the northerly direction. So, for example, our initial speed, initial velocity is 5 meters per second due north. So we could represent that as 0I plus 5j. There's no easterly component and it's just 5 due north. But I find it easiest to represent this as a vector. So 0, 5. So the first component is my east-west and my second component is my north-south. So I'm going to write things in vector form. So U, if I go back, U is going to be 0, 5. V is my final velocity, and it says that it's due east at 4 meters per second. So this is just 4, 0. Acceleration is unknown, and we need to work that out. T we're given is 40 seconds, and our final position is also unknown. Okay, so let's look at question part A. We need to work out the acceleration. We don't know r, so we need an equation that doesn't involve r. The equation to use is v equals u plus at. And let's just fill in the values. V is 4, 0 equals u 0, 5 plus t is 40, so we get 40a. Okay, let's move the 0, 5 to the other side. 40a. So I get 4 minus 5 equals 40a. And dividing both sides by 40 gives a is 0.1 minus 0.125, which is the same as 0.1 I minus 0.125 j meters per second squared, which is what part A told us to work out. So that worked out fine. Great. Let's move on to part B. So for part B, now we've got to work out the position vector at the end of the 40-second period. So we've got to work out R. Now from part A, we actually know what A is, so we can fill in our value of A. A is no longer unknown. A is now 0.1 and minus 0.125. Okay, so we want an equation that gives us R. Well, the easiest equation is R equals R0 plus UT plus a half AT squared. Okay, so this is a bit like the S equals UT plus half AT squared equation, but we have this extra term here, R0, which is our initial position. And it's quite useful to know this equation when we're working in 2 dimensions, because often the initial position is not 0. That said, in this question, if we go to the top, it says the jet ski is at the origin. So actually, in this question, our R0 is just 0, 0, the origin. U is 0, 5. T is 40. And we get plus a half. A is 0.1 minus 0.125. And T is 40 squared. And this is R. So now let's work this out. R equals, well, 0, 0 does nothing. 0, 5 times 40 gives us 0, 200. And 40 squared is 1,600. Half of that is 800. So I get 800 lots of 0.1 minus 0.125. So that's 0, 200 plus 80. 800 times minus 0.125 is minus 100. Okay, and 0 plus 80 is 80. 200 minus 100 is 100. So this is my final position in meters. It's 80i plus 100j meters. Okay, and that's part B. Let's move on then to part C. A jet ski is travelling southeast t seconds after it leaves the origin. Okay, so let's look at so now we don't know r anymore. We still know our initial speed, velocity is 0.5. Our final velocity v we don't know. A is still the same, and now t is unknown. But we do know something about v. We know that it's travelling southeast. So let's use an equation. We know nothing about r, so let's ignore r in our equation. Let's have an equation that doesn't involve r at all. The easiest one to use here is v equals u plus at. Okay, well v is u 0.5 plus 0.1 minus 0.125 t. That's sort of an equation for v. If we actually multiply out the brackets, or sort of combine these two vectors, the top component 0 plus 0.1t is 0.1t, and the bottom component 5 minus 0 is 5 minus 0.125t. So this is my velocity at time t. It's given by 0.1t in the I direction and 5 minus 0.125t in the j direction. The question says that at time t, the jet ski is travelling southeast. Well, that means that the I component, the easterly component, and is the negation, the negative of the j component. Let's think about that. So I'm just going to draw a diagram here. So if we're travelling southeast, we're travelling in this direction. So my I component is that, and my j component is that. And so you can see that the j component is the negative of the I component. This is these two sides are the same length. Okay, so that means my I component, 0.1t, is the negative of my j component, 5 minus 0.125t. Okay, so let's rearrange this and solve for t. I get 0.1t is minus 5 plus 0.125t. That gives 0.025t equals 5, so t equals 200. So that's how I've worked out t in C part 1. Okay, and then finally, find the velocity of the jet ski at this time. Well, for part 2, I can go back to, I actually worked out this formula. Let's just, my general formula for velocity is this thing I've left at the bottom, v equals 0.1t and then 5 minus 0.125. So I'm just going to substitute t equals 200 into this. I get 0.1 times 200, and I get 5 minus 0.125 times 200. And that gives me 20 and minus 20. So that's my velocity at time t, at time 200. It's 20 to the east and 20 to the south. So you can indeed see that the velocity is correctly travelling in the southeast direction.